Hey, what's up, my dear students? It's Naresh Babu. Welcome back to Physics Crash. Students, in this session, I'm going to discuss about Neet MCQs from 2021 to 2023 in moving charges and magnetism. Let us start the game. Moving charges and magnetism. Neet MCQs 2021 to 2023. Here the first question. A very long conducting wire is bent in semicircular shape from A to B as shown in figure. So in this figure, a long conducting wire is bent in semicircular shape from A to B. The magnetic field at point P for steady current configuration is given by. So we have to find magnetic field at point P due to this current carrying conductor. So it was given in NEET 2023. Here the options. From these options we have to identify correct answer. Solution. See, net magnetic field at point P. See, this entire conductor I divided into three parts. Due to first part B1 and due to second part, that is semicircular shape, B2, and the third part, that is one end finite, other end infinite, that is B3. Okay. So B1, what is B1? B1 means first part, that is one end infinite, other end finite, current carrying conductor at point P, that is mu naught I by 4 pi r. But the direction of magnetic field at point P due to this conductor into the plane. So if you apply right hand thumb rule, you will get into the plane. Into the plane means I consider minus z axis. So I got minus mu naught I by 4 pi r. Okay. So here mu naught means you know that magnetic permeability. Okay. Then what about B2? B2 means the current carrying conductor, that is semicircular current carrying conductor. Okay. Due to this semicircular current carrying conductor, the magnetic field at point P is B2, that is mu naught I by 4r. Okay. Is it into the plane or away from the plane at point P? So here also we can apply right hand thumb rule. So at point P, due to this circular current carrying conductor, that is away from the plane, that is we can write mu naught I by 4r. Okay. And third part, that is due to this third conductor at P, that is B3. So this third conductor, one end finite, other end infinite. Due to this current carrying conductor at point P is mu naught I by 4 pi r. But what about direction of magnetic field at point P due to this conductor? That is into the plane. Into the plane means minus mu naught I by 4 pi r. So if you simplify, minus mu naught I by 4 pi r minus mu naught I by 4 pi r, that is minus 2 mu naught I by 4 pi r plus mu naught I by 4r. So here if we write commonly outside this mu naught I by 4r, then inside the bracket we will get 1 minus 2 by pi. So it is a positive value, that means away from the page. So from the given options, of option B is the answer, my dear. Now we will go with second question. Here the second question, that is a long solenoid of radius 1 millimeter has 100 turns per millimeter. Okay, here one solenoid is there. Okay, it is a long solenoid having radius 1 millimeter and it has 100 turns per millimeter. Okay, if 1 ampere current flows in the solenoid, the magnetic field strength at the center of the solenoid is. So we have to find, if 1 ampere current is flowing through this solenoid, what about magnetic field at its center? It was given in NEET 2022. So here the options, from these options we have to identify correct answer. Solution. magnetic field strength at the center of the solenoid is, that is B is equal to mu naught Ni. Okay, here mu naught means magnetic permeability for free space, small n means number of turns per length, that means total number of turns per length, into I, that is current flowing through the solenoid. So we will get mu naught small n place capital N by L, that is length of the solenoid, into I. So here mu naught value 4 pi into 10 power minus 7, total number of turns 100 by length millimeter, that means 10 power minus 3 meter, into current, that is current 1 ampere into 1. So if we simplify, we will get 12.56 into 10 power minus 2 Tesla. From the given options, option A is the answer, my dear. Now we will go with third question. A wire carrying a current I along the positive x-axis has length L. It is kept in a magnetic field, that is B is equal to 2I cap plus 3J cap minus 4K cap Tesla. The magnitude of the magnetic force acting on the wire is, it was given in Neet 2023. So here the options, from these options we have to identify correct answer. Solution. So here magnetic field is acting in xy plane, okay, which makes theta with the direction of length of the conductor, which is acting along x-axis. So we have to find magnitude of force acting on that wire. So magnetic force acting on the wire, that is F equal to I into L cross B. Okay, so L is a vector, that is length of the wire. It is acting along x-axis, that is Li cap, cross vector B given 2I cap plus 3J cap minus 4K cap. So if we do cross product, then we will get 3L K cap plus 4L J cap into I. So I distribute into the bracket, then we will get 3IL K cap plus 4IL J cap. So we got force vector, that is 3IL K cap plus 4IL J cap. Now magnitude of force, that is root over 4IL whole square plus 3IL whole square. Then we will get root over 25 I square L square. That means 4IL whole square means 16 I square L square, plus 3IL whole square means 9 I square L square. So 16 plus 9, 25. So we will get root over 25 I square L square, that is equal to 5IL. So we got magnitude of force acting on the wire, that is 5IL. From the options, option B is the answer, my dear. Now fourth question. Here an infinitely long straight conductor carries a current of 5 ampere as shown. So here an infinitely long straight conductor, that is PQ, okay, through that conductor 5 ampere current is flowing, okay. An electron is moving with a speed of 10 power 5 meter per second parallel to the conductor. So here electron is moving parallel to this conductor with a speed 10 power 5 meter per second, okay. The perpendicular distance between the electron and the conductor is 20 centimeter. See here, the perpendicular distance between electron and conductor is 20 centimeter, okay, at an instant. Calculate the magnitude of the force experienced by the electron at that instant. So we have to calculate magnitude of force experienced by this electron due to this current carrying conductor PQ. So it was given in Neet 2021. Here the solution, here the options. From these options we have to identify correct answer. Solution. So here from the given figure, okay, we have to identify magnitude of force experienced by this electron due to this current carrying conductor PQ. the velocity of electron is 10 power 5 meter per second. Okay, so the perpendicular distance between these two, that is 20 centimeter given, so we can convert into 0.2 meter. Okay, see, we know that force on that charge due to this current, okay, that is QVB. That means magnetic force due to this current carrying conductor on that charge on that electron, that is F equal to BQV. Okay, so here Q means electron, V means V, B means that is mu naught I by 2 pi R. Okay, why it is mu naught I by 2 pi R? Why? Because it is a infinite current carrying conductor. Okay, the direction of magnetic field, okay, on that charge, if you apply right hand thumb rule, it is away from the plane, so which is mu naught I by 2 pi R. Okay, so here if you substitute in the value of E 1.6 into 10 power minus 19 and V velocity given 10 power 5, okay, mu naught is there, mu naught by 2 pi is there, so I will multiply and divide with 2, then I will get mu naught 2 mu naught by 4 pi. So 2 into mu naught by 4 pi value 10 power minus 7, I value into 5, that is 5 ampere, by R value, that is 0.2 meter. So if you simplify, we will get 8 into 10 power minus 20 Newton. Okay, from the given options, option D is the answer, my dear. Now we will go with fifth question. That is, a thick current carrying cable, radius R, carries current I uniformly distributed across its cross section. The variation of magnetic field due to the cable with the distance R from the axis of the cable is represented by. It was given in Neet 2021. Okay, so from these options we have to identify correct graph. Okay, these are the graphs between B and R, that is magnetic field and distance of point from the conductor or from the cable. Okay, here the solution. So here it is a current carrying conductor whose area of cross section, it is area of cross section having radius capital R. Through this current carrying conductor, I current is flowing. Okay, so we have to find variation of magnetic field with respect to distance R. Okay, for suppose point is inside the conductor, that means small r is less than capital R, then we will get B is equal to mu naught I by 2 pi R square into R. Since for pi R square area, we will get current IR square by R square. So if you substitute I place this IR square by R square, then finally we will get B is equal to mu naught I by 2 pi capital R square into R. That implies, see, from this we can write B directly proportional to R. Okay, outside conductor we have the formula B is equal to mu naught I by 2 pi R. Okay, that implies B is inversely proportional to R. Okay, so from 1 and 2, that means from these two relations, that is B directly proportional to R, B inversely proportional to R, we will get the graph, that is option 3. Okay, now we will go with next question. Here the sixth question, in the product of F is equal to Q into V cross B, that is QV cross bracket of Bi cap plus Bj cap plus B naught K cap. For Q is equal to 1 and V equal to 2I cap plus 4J cap plus 6K cap, and F is equal to 4I cap plus minus 20J cap plus 12K cap. What will be the complete expression for B? It was given in NEET 2021. Here are the options. From these options, we have to identify correct answer. Solution. We know that force on the charge, okay, that is F equal to Q into V cross B. So F given 4I cap minus 20J cap plus 12K cap. Okay. That is equal to Q place we will write 1 and V cross B, that is I cap, J cap, K cap, 2, 4, 6. These are the coefficients of I cap, J cap, K cap in vector V. And what about coefficients of I cap, J cap, K cap in vector B, that is B, B and B naught. Okay. So here we will calculate V cross B. Okay. After calculating V cross B, if you compare coefficients of I, J, K, then for coefficients of I, if you compare on left both LHS and RHS, for coefficients of I, if you compare both LHS and RHS, you will get 4 equal to 4B naught minus 6B, that is equation 1. Now if we compare coefficient of J for both LHS and RHS, we will get minus 20 is equal to minus 2B naught plus 6B, that is equation 2. Now if we compare coefficients of K for both LHS and RHS, we will get 12 equal to 2B minus 4B, that is equation 3. From equation 3, we can write B equal to minus 6. Substitute this value of B in equation 1, we will get B naught is equal to minus 8. Therefore, finally we will get expression for magnetic field B, that is minus 6I cap minus 6J cap minus 8K cap. That is from the options, option B is the answer, my dear. Now we will go with 7th question. A uniform conducting wire of length 12A and resistance capital R is wound up as a current carrying coil in the shape of an equilateral triangle of side A square of side A. The magnetic dipole moments of the coil in each case respectively are. It was given in NEET 2021. Here are the options. From the options, we have to identify correct answer. Solution. Magnetic dipole moment, we know that is M equal to N into I into A, where N means number of turns, I means current, A means area of loop. See, equilateral triangle, we will get number of turns, that is N is equal to 4, and area of this loop, that is area of equilateral triangle, root 3 by 4 A square into I, that is root 3 IA square. See, for square loop, we will get M equal to 3IA square, that is number of turns 3 into current I, area of the loop A square. Okay. So from the options, for equilateral triangle, root 3 IA square, for square loop 3 IA square. So from the options, option A is the answer, my dear. Okay, that's about this session, my dear students. I hope you like this video. If you like it, please put a like. Okay, that will give more encouragement to me to do more videos. Thank you for your support. Thanks for watching my video. Please share it and subscribe it. Bye, students.